All right, let's take a look at how the lab is organized. Let's start with the hardware layer. First, we have a number of enterprise-level physical servers organized in a cluster, part of the same network. In each physical server, we have 6 network cards, 2 of them dedicated to SAN connectivity, and 4 to virtual machines and management, 32 gigs of RAM, and a KVM controller. We've got multiple redundant switches to serve each of the 2 physically isolated networks. The regular virtual machine network, green color, and the SAN network, red color. It's a best practice to run your SAN traffic on an isolated network segment for better performance and reliability. In fact, running your SAN and your regular network on the same segment is a recipe for disaster. For shared storage, we've got an array of Dell EqualLogic SAN units, physically cross-connected to 2 redundant SAN switches. Each SAN unit has 6 gigabit network uplinks to the switch, 3 of them connected to SAN switch 1 and 3 to SAN switch 2. The IP address of the iSCSI SAN, the iSCSI target, is 192.168.4.200. You're going to need this IP address to add a shared storage to your ESXi server. The iSCSI SAN has 2 LUNs, Shared Storage 12 and Shared Storage 14, that you can use to place virtual machines on, and also plays a critical role to installing and configuring VMware's advanced features such as vMotion, HA, DRS, fault tolerance. You need shared storage for all of these features to work. The 2 LUNs allow you to do storage vMotion, which is to migrate running VMs from one LUN to the other. Each one of the physical hosts, or servers, has 2 gigabit network cards cross-linked to the SAN switches for multipathing. Network card 1 is plugged into SAN switch 1, and NIC 2 goes to SAN switch 2. We use 2 network cards for SAN connectivity, so that you can configure SAN multipathing for redundancy, but also to bind the 2 network cards to increase performance. On the same network, we have an NFS server, IP address 192.168.4.222, that you can use to learn how to mount and work with NFS shares. And also, we've got a Pixie server, IP 192.168.4.2. Now let's take a look at the regular virtual machine network, green color. The VM network has an Active Directory server called VIAD with an IP address 10.1.20.4. We use it as domain controller to authenticate and authorize all users and computers in the network. It's also used to integrate VMware ESXi server and vCenter authentication with Active Directory. There's a DNS server sitting at IP address 10.1.20.3. DNS is a required component for most of the VMware features to work properly. Now, down here we've got Microsoft SQL Server, called VApp1, with an IP address of 10.1.20.5. SQL Server is there to host all of the VMware vSphere databases. For example, vCenter Database and Update Manager Database. Right here we've got the shared instance of vCenter Server, called VApp3, with an IP address of 10.1.20.6, and fqdn vapp3.lab.vadmin.com. You can use this shared pre-installed instance of vCenter Server to practice the advanced VMware features such as vMotion, high availability, fault tolerance, DRS, etc. This is where you can find Windows and Linux virtual machine templates that you can use to quickly provision new virtual machines. As I said earlier, each one of the physical servers has 4 gigabit network cards plugged into the virtual machine network switches. The reason we use 4 network cards for VM network traffic and connectivity is that 1. You can configure vMotion with its own dedicated NIC. 2. You can set up the management network with 1 or 2 NICs for redundancy. This allows you to experiment with link aggregation to achieve better performance and multipathing for redundancy. 3. You can do the same with the network cards dedicated to VM traffic. With 32 gigs of memory and superfast SAN, each physical host can easily run 10 to 15 or more virtual machines. Working with DRS does require a number of virtual machines, so that won't be an issue here. To manage your physical host, your ESXi server, and the rest of the virtual infrastructure components, you'll be provided with remote access to a 64-bit virtual machine running Windows Server 2008 R2. This is your management station that you can always access even if you power down your dedicated physical host or ESXi server. Now, after signing in, you'll receive a username and password so that you can connect to your own management station through Microsoft Remote Desktop Protocol, RDP. If you're connecting from a non-Windows-based computer, you can use one of these RDP clients for Linux, Solaris, or BSD use. Our desktop, and for Mac OS, you can use TS Client X. You can even access the lab from your iPad. You just need to install the free 2X app from the Apple App Store. So no matter where you are located, different city or continent, you can use Windows Remote Desktop to access your management station and do all of the testing and training. With our standard package, when you log into the VMware lab, in addition to your main physical host, for example, ESX100 IP 10.1.20.100, you have an access to at least one or more shared ESXi servers. For example, ESX60 with an IP 10.1.20.60. With the same specs connected to the same shared storage so that you can set up vMotion, HA, DRS, FT, and all of the advanced VMware features. And without fast shared storage, you know that won't be possible. Installing ESXi Server on the physical host can easily be done with the help of the Remote Keyboard Video Mouse Controller, aka KVM. KVM is an interface card that provides out-of-band management facilities, meaning you can manage and configure server setting even if the server is powered down. It has its own web interface, network connection, and access to the server's system bus. With the KVM controller, you can power up and down your host, mount virtual DVD images in order to install ESXi. You can also access server's remote video console through a supported web browser, Internet Explorer, which gives you the ability to manage the physical host as if you were sitting in front of it. As our virtual infrastructure configurations grows in complexity and VMware releases new products or a whole new line of products, we are faced with the same expectations to deliver tested and innovative solution by reducing not just the cost, but also to speed up the whole process of testing and training. Now, this is a real challenge if you don't have all of the resources. Challenge number 1 is, we don't have sufficient servers, multiple network cards, lots of memory, fast iSCSI SAN or an NFS storage, enough switches or routers, AD, DNS servers, and the list goes on and on. In other words, building fully functional VMware Lab is expensive, and it does require lots of resources. So how can you reduce the cost, the time to plan, install, configure, validate, and support complex virtual labs for training, practice, or proof of concept? Well, there is a solution, and it's time for you to look at private cloud-based environments as a way to address those challenges. Alright, so with our cloud-based VMware Testing and Training Lab, we offer a new method of delivering complex testing and training environments that overcome many of the challenges of traditional testing environments and methods. By adopting the private test cloud methodology, you are benefiting from new and better ways for your IT staff and users to access services which traditionally used to be extremely hard to configure and very expensive, immediately and at the fraction of the cost. Our Test Cloud offers an improved means of infrastructure management and supports faster service delivery. With VMware Hosted Test Cloud, you can forget about your capital expense concerns, the need to ensure service automation, ease of consumer use and access. Also, you are no longer dependent on your internal availability, which may be limited depending on the resource investment you made in your infrastructure. The cloud-based VMware Lab is a way to reduce the required time and investment in infrastructure because it delivers virtualized applications, operating systems, networking, and server resources on demand. With our VMware Lab, test and training environment, in the cloud CIOs, IT managers, test and development teams, system administrators will realize the benefits that cloud computing can provide for testing and training initiatives, such as reduction in IT operating and capital costs by avoiding the investment into underutilized servers and network infrastructure. Significantly reduced time to take new technologies and innovations through the test or proof of concept cycle so that they are delivered quicker and with higher quality. Labor cost savings related to time spent installing, configuring, and supporting dedicated test or training environments. More efficient resource management, achieved by optimizing the existing server and network infrastructure for use with production applications only.